Okay, so now we are going to start with the contents of this course actually, right? That is objects and classes. So far, whatever we did was more of a recap of already seen concepts, right? So let's start a discussion. And if you remember on day one, we discussed some differences between structured programming and object-oriented programming, right? This is the same discussion. A quick recap that we said that in a structured programming, whatever problem you have, you break that problem into sub problems, right? And for example, I had given you example of a calculator that if you have to add, subtract, and multiply, then what you will do is maybe you will make three different functions, right? This is your main program. All the data is in the main program. So whenever you need to add two numbers, what you will say, you will maybe pass some data to this function. It will do its job and it will give you back the answer, right? And similarly, this function can also be calling other functions. It is also possible. It depends what the function is doing. Okay. So I told you that the easier way to understand structured programming is that this main, it is like a boss, okay, who is not doing anything, who has some data, and he has many employees or many robots, and every robot is good at one type of work. So whenever this boss needs maybe some information on history, he will ask this robot, it will give him back the answer, right? So in other words, main is not doing anything. He's just passing data to different functions, getting back the results, and eventually solving the problem, right? So this is the idea of structured programming. Then if you remember, we discussed about objects. So I told you that object is anything in the real world, right? And if you remember, I had given you example of a fan and a car and a student, right? So we said an object is defined by two things. The properties or attributes of that object. For example, for fan, we said it has three blades, right? Its color is white, its price is say 5,000 and so on. So these are the attributes. And then the second thing was the operations, or what you can do with the fan. So we had said we can turn it on, we can turn it off, or we can change the speed of the fan. And when we are talking in terms of programming, right? So all of these properties, like it has three blades, its color is white, its price is 5,000, we call it data of an object, right? This data is actually the properties or the attributes of an object, and what you can do on, off, change the speed and so on. These are actually operations which in a program become functions of that object, right? So in other words, all what you have in data, they will be always noun, right? For example, price is a noun, color is a noun, and whatever you have in function, it will always be a verb. Turn on, turn off, change the speed, right? So these will always be verbs, and data will always be noun. So this is a more formal way of saying what we mean by an object. So we said an object is something which has some data and some functions, right? And of course, in your program, you can have multiple objects. For example, if this is a university, so maybe we have some object called student. So student will have different data and different functions, right? You will have your GPA, your address, and your enrollment number, so on. And then you can see your GPA, you can see your attendance and so on. Similarly, faculty will have some other data. The data of the faculty would be maybe designation, salary, and the functions would be mark attendance, change attendance, mark result, and so on. And then maybe you have something like administrative staff, like the head or deans, who will have some other data and functions, right? So in a program, when you are writing a program in object-oriented paradigm, you will have multiple objects, and different objects will be, you can say, talking to one another, right? For example, when when I mark your attendance, of course you can also view it. It means there is something which is changed and you are able to view it, right? So it means there is some sharing of information between these different objects. Okay, so we'll come back to this later when we actually write some program. Okay, so in the initial discussion, I will not be writing any program. We'll be just developing some ideas which will help us in the subsequent discussion. So another very important concept that we use with object-oriented programming is called abstract data type, right? And as I keep telling you, it is a typical question that someone might ask you once you appear for a job interview, right? They can say, okay, tell me what is ADT, or what is an abstract data type, right? So the simplest way to understand what is an abstract data type is by looking the examples around us. Okay, if we try to define it, we know the simplest definition is that we know what something can do, but how it is done, we don't know, right? So it means we know what we can do, but the details of how it is done is not clear. Now, maybe it does not make much sense, but if we relate it with some real world example, so let's take an example of a car, right? When you have to drive a car, car has an interface like the steering and the pedals, right? So you only need to know how the steering works and how the pedal works, and then you can drive a car. Okay. You don't need to know that when you press the pedal, what is going on inside the engine. When you start the car, what happens when you press the accelerator, what is going on here. When you press the brake, what changes here, right? So these are the details which you don't know. These are hidden from you, and they have to be hidden. We don't need to know. If our objective is to drive a car, for driving a car, these details are not important. Yes, if you want to be an expert who can actually repair this engine, then you need those details, right? But if your objective is to drive a car, this is what is important. This is not important, right? So we know what this car can do. This car can move, this car can park, this car can be refueled, this car can be turned. So for all of this is your interface. You don't need to know all of these details, right? And a similar example is, let's I keep giving you this example because it is easy to understand, right? So this is a fan, and we know if we have to turn the fan on, we press this button. If we have to change the speed, we have to rotate this regulator, right? But you don't care that when you press the button or when you rotate this regulator, what is happening at the back end. There's a circuit, right? Maybe some resistance is changing and how the speed is being controlled. These are the implementation details. This is the hidden circuit diagram. But if we want to turn on the fan or turn off the fan, this we don't care, right? We are an end user. This is the job of the person who is designing the fan, that how this circuit would work. As an end user, I know what I can do. I can turn it on, I can turn it off, and I can change the speed. And if I have to turn it on, I just press this button. I don't care what is the circuit that is completed when I press the button and how the fan starts revolving, right? So this is what we call abstraction, right? Hiding details, hiding some implementation details. There's another example which is slightly related to programming, right? Maybe suppose you take an example of integers, right? Suppose there's an integer data type in some programming language. In almost every programming language, you have this data type. So you see, you can also relate it with data abstraction. Why? Because in an integer, you can store any positive or negative value, but you cannot store a real number in it. You can add two integers, you can subtract two integers, but you don't know what is happening at the back end. How this, you don't care how this integer is actually stored in the memory. Maybe in some binary form, if it's a two, it is something like this. Maybe but you don't care, right? If you want to add two numbers, you simply write a plus b. You don't care how their binary bit by bit they are added in the computer, and then you get back the answer, right? So this is also to some extent an example of what we call data abstraction. So now if we try and come back to our definition with this knowledge, now we are in a better position to understand what is an abstract data type, right? So in an abstract data type, we know what we can do, but how it is done, it is hidden from the user, right? And if we formally define it, in an abstract data type, you have some data. For example, fan, the data of fan, that how many blades it has, what is the color, what is the price. Then you have something which is called operation, that what you can do. We can turn it on, we can turn it off, we can change the speed and so on, right? And the third point is, this is the term I didn't tell you as yet, but I'll explain it. That if you remember that diagram, what we did, we had data and we had functions and we put them together, right? And this is what the first thing that we'll study today, this concept which is called encapsulation, right? So let me just discuss this concept on the board, because this is very important, and again a typical question that people would ask you in an interview, right? So you see, uh, maybe let's try and understand what do we mean by this term encapsulation, right? I told you on day one as well, but I had asked you to hold on and we'll come back to this discussion at a later stage, right? So now is the time. Okay, so if you see this, so the first thing that might come to your mind is maybe capsule. Okay, because this is the nearest thing that comes to our mind when we see this. Okay, so you see, what is a capsule? A capsule is something like this, in which you have some medicine, right, which is hidden, which is packed inside something. So you see, capsule is a noun. If you make it encapsule, it simply means to make a capsule, right? So capsule is basically a packing, a package in which inside you have some medicine or anything you want, right? Now, what is the capsule in programming? So you see, this is our fan. Okay, if I want to make a capsule of it, what I will do is say this is my capsule. This capsule will have two parts. One part is data of the fan, which we already discussed, and the second part is all the functions of this fan, turn on, turn off, and so on, right? So we have data, we have functions. We put them together in a package, and that package is basically what we call, this is our fan. And this process is called encapsulation. Means encapsulation means we are making a capsule. Okay, what is the capsule? Capsule is containing this, capsule is containing some medicine maybe. But the capsule in programming, it is containing data and functions together, right? The same thing which I showed you on slide number 1. So since I have not written any program for this, so maybe it is a little hard for you to understand what is going on here. But when I will write a program, right, maybe you have already seen structures, right? So it will be very similar to relate actually what is going on here, right? So I would request you to kindly hold on till I write a program, and then you will be in a better position to link how this is linked with the program. Okay, so now let's discuss something further. Let me just redraw. And okay, so far we are discussing, I'll write it here, abstract data type, and within abstract data type, a feature of abstract data type is encapsulation. Okay, so now suppose I have some data type which is like this. Okay, and then this is my main program. Okay, so let's make it like this. Within this, I told you there are two things. There is some data and there are some functions. Okay, we put them together in a capsule. Now suppose this is your main program. Main program wants access to data or functions or something like this. Okay, so you see, now what we'll do is we'll allow, we will have some restrictions. Why will become clear, right? That why we are doing this. For the time being, we are discussing what we are doing. Now what are those restrictions? We say, okay, if main needs something, then main cannot directly come here. This we will not allow. Okay, what will happen is that, for example, suppose there is some data here, say X, which is 5. Main needs this data, but main cannot directly do this. Main cannot directly write cout X. What will main do? Main will go to somewhere, this function, and main will request this function that, okay, I want this data. Okay, and then this function will do the job for the main. So in other words, maybe and another example would be that suppose this is the boss, right? And maybe this is the PA, and this is some client. So you see, client cannot directly go to the boss because we are saying this is not allowed. Whenever client has a requirement or it has to convey a message to the boss, the client will go to the PA, which is okay, and the PA will contact the boss, which is okay. Boss will respond back to the PA, and PA will get in touch with the client. So you see, instead of directly accessing the boss, this client is requesting something through this PA. Or you can say that suppose you have some application which you want to be communicated to the HOD. So the HOD does not directly see student. HOD will say, okay, first you go to the student advisor. So you will submit your application to the student advisor, and student advisor will actually submit it to the HOD. So in other words, if we come back here, what we have done, we have restricted access to this. You cannot directly access the HOD. This part you cannot access. You go to the student advisor, and then the student advisor has access to HOD. So this is basically what we mean by another concept which is related to encapsulation. This is what we call data hiding, or you can say information hiding. What do we mean by information hiding? That we are not giving direct access to the information. There is an indirect channel, right? And you might be thinking that why we are doing this. Maybe this is inefficient, or why we are introducing a new channel. But this, why we are doing this, this would become clear once we write some programs. Okay. Okay. Now let's put these pieces together, because maybe current discussion would not be very meaningful unless we write something. Okay. So you see, previously you have already worked with structures, right? Maybe you made some structure, right, in which you had a structure. I'm not writing the exact syntax, I'm just telling maybe you made a structure like point which had like two coordinates x and y. Okay, so this was like your point, which had say x and y, and in your program what you could do is you could do point p, and then you could write p dot x, p dot y. Okay, you can give them values or you can print them, you can do whatever you want with them. Okay, now what we are doing here is when you actually do make a structure, what do? You create your own data type. Okay, because you see point is not a data type which exists already in C++. There are very few data types which with which you are already familiar, right? But once you write this say int x, integer is a data type which already exists. But once you write point p, now you can compare both of these. Both of these are actually exactly the same thing. The only difference is that in this top one, this is a built-in data type and this is a data type you have created. Otherwise we have the same syntax. This is variable and this is data type, and the same is here. This is variable and this is data type, right? So it means you have created your own data type and you can mix. For example, instead of a point, if you have a student structure, you can have an integer, you can have a float, you can have a string which is name of the student. So you can mix all the data types together, put them together in one package or one capsule, right? And that is a structure. So this is very similar to what I'm telling you right now. So in in case of object-oriented programming, instead of using structures, what we use is something which is called a class, right? So if you were previously using the keyword struct, when we write a program here, we'll be using the keyword class. For the time being, rest everything is very similar, right? For the time being. So you see, you to write struct point, I'm writing class point, and within this maybe you had written something like this. Okay, so for the timing, let's not write class, right? Let's write it a struct. Okay, so you do this, and now this is a new data type. So within the main, now you can make use of this and you can write say point p, and within this you can write p dot x gets the value 2 and p dot y gets the value 3, right? And then you can do whatever you want. Now instead of this, as I told you, that what we are going to do is we are going to replace this keyword struct by a different keyword that will be calling a class. Okay, let me just get rid of this. Okay, so let's, yeah, so no struct, rather we'll have this keyword class. Okay, now if I draw it, so maybe so far we have done this. This is our capsule, and within the capsule point I have two data members x and y. Okay, but now when you write a class, there are few things that will change. Okay, now what are those? You see, with the structure we were able to directly access this x and y from the main. Okay, when it was a structure, you are directly writing in the main p dot x, p dot y, these two statements. But when you are using a class, I told you in the beginning that we don't want this, right? We do not want direct access on our data. We want to restrict it. Okay, so that's why if you are using the keyword class, this would not be allowed. And why this would not be allowed, I'll make a separate program and then we'll discuss further. Okay, but so far, if you have any queries, please let me know and then we discuss further. So let me just tell you what we have seen so far. We have seen what is an abstract data type. Abstract data type means we know what we can do. We don't know how it is implemented. Implementation details are hidden. I had given you an example of a car that when you drive a car, you know, if you press the pedal, the car will move. If you press the brake, the car will stop. But you don't care what is going on in the engine or anywhere else in the car when you are pressing a pedal. Okay. So this means those details are hidden from you. Then we had seen that example of a fan, that if you want to turn on the fan, you simply press the button. You don't care what is going on in the circuit, how the electrons are moving, how the circuit is being completed. So those are the details that are hidden from you. Then we saw another related concept which was related to abstract data type, which is called encapsulation. So encapsulation is like making a capsule, and within that capsule, what are we putting? We are putting some data and functions together. We have not seen the program yet, right? I just told you verbally that when we say encapsulation, so remember the capsule, and within that capsule we have two things: data like integer, float, string, whatever you have, and some functions. Okay, will this will make more sense when I actually write a program. And then we saw one last concept which is called information hiding. Again, we have to write a program for that, then it will be more clear. But the concept is that we do not allow direct access to some parts of that capsule, right? So in a capsule, you have two things: data and functions. So normally what we do is, normally we say, okay, you cannot directly access data, you have to request a function. Okay, this is the general concept. And I had given you an example that if you have an application for the HOD, you cannot directly access HOD, you have to go to student advisor and then submit the application, and student advisor will forward it to the HOD, right? So this was some, you can say, conceptual discussion without writing programs, right? So if we have any confusions or queries till now, please let me know. Okay, now let me write a small, not a program, but let's extend the discussion by writing some small pieces of code, right? So I told you that just like a structure in object-oriented programming, the equivalent is a class, right? And they are not exactly the same, but you will find many similarities between structures and classes, right? So once we are in the beginning of the semester, it's a good idea that whenever I am writing a class, you compare it with the structure, okay? So that understanding would be easier. So let's make a class or a data type which we call point, okay, just like we did for structure. So the only thing is that instead of struct here, I have written the keyword class. Okay. Okay, now I'll be doing it a bit formally, right? So within this class, we'll make two sections. Why two sections? And at the same time, I'll be making that capsule so that you understand what is going on. Okay. So you see, when I'm drawing it, I normally make one section for data and one for functions. Okay, I say this is data and this is functions. And I also keep telling you that access to this is not allowed. Access to this is allowed from outside, right? From the main. So now how you do it in a program? It means this is different section, this is different section. So if you want to restrict access to something, right, you have a keyword in C++ that is called private. So how do we write it? You just write this keyword private and you put a colon here. Okay. And if you want to allow access to something from outside this capsule, you have another keyword which is called public. Okay, so you see so far what I have done, I have not done anything. I have simply written the keyword private and public. Now, by writing this, what actually has happened? We have anything that I will write here. Okay, and normally I write data here. Okay, it means this whole part is corresponding to this part on which access is not allowed. And whatever I write here, which we are calling public, this part corresponds to this where access is allowed, right? So presently, I have not written anything within this class. I just have introduced two keywords, private and public. And private is something which you cannot access from outside the class or outside the capsule. Just refer to the diagram on the right. And public is something which you can access from outside this capsule. And when we say outside this capsule, we mean main program. Okay. So yes, please, if there are any queries, please let me know.